And let's see if I forgot anything. Yeah, so as I said, this won't quite plot it yet because we didn't actually tell it to plot it yet. We only read in the file. And then, am I telling it to, okay, never mind. I was just gonna say, I wanna give it a file name, which in this case, yeah, okay. What we need to do is go to the canvas, and we will have a few different variables that we will initialize. We will have a frame IDX. Yes, 0. This is the frame index for which the frame we're looking at. Self.init data. We'll define these functions in just a little bit. And we'll just leave it like that. And then init data self. We will say harmonics, and harmonics is 12. Self.data equals that. Self.data harmonics equals yeah, okay, numpy dot zeros 4 times n harmonics. So the reason we're using 4 is we will be plotting harmonics later. Numpy dot zeros 4 times n harmonics. Okay, self.n0 equals 0, self.harmonics visible equals false. And then these this data, these harmonics, we'll actually use a little bit later, but for now, let's do calc data self. We do self.frame result equals self.ap is the audio processor .calc frame. We invoke that function self.frame IDX. Okay, and then we do self.calc UI. The reason we refactor this into its own thing is because this one is quicker. The calc UI is quicker, but the calc frame is a little bit slower. So calc UI self. Then we do, so the LW log intensity windowed result self.frame frame result LW, and then we'll define some, y top equals LW.max times 1.1. The reason we multiply by 1.1 just to leave some space up at the top, so it's easier to read the plot. Y mid equals LW.min, and then y bot is the bottom, and we'll do top minus, well actually y top minus y mid times negative 0.1 plus y mid. So we just do we can do negative 0.1 or negative 0.1, and then self.data harmonics y 0 stride 4 equals y mid. The first value tells you where to start, the second one tells you where to end. In this case, I don't put a value in between these two colons, which means that we don't end, we just do for the entire array. And then the third value, which is 4 in this case, tells us to step by 4. So data harmonics, and you can play around with this in Python too. 1 through 4 equals y top. Okay, self dot data harmonics. I don't know why there's this pipe looking thing. Hello. Anyway, try opening that again. Okay, that's better. Okay, so 2 through 4 is y bot, and self dot data harmonics y 3 through 4 equals y mid again. What we're essentially trying to do is we have a line that's at y mid, and then we send it to y top, then we send it to y bot, then we send it back to y mid, and then we go on with. So effectively it'll be a line, but with vertical lines inserted in there. Okay, then f naught equals note to freak self.end naught. Okay, for I in range self.data harmonics x dot shape 0 divided by 4. Okay, and then we do and mult. What we're doing here is we're populating the x. We populated the y's. NumPy did that for us for every harmonic that we're going to plot. But here, I+1, here we're doing the same, but for the x's, we just can't do it in a simple slice like that. We have to have a loop for this. Freak to note f. So what we did, we took the multiplier, right, which is I starts at 0, so nmult starts at 1, and it's whole numbers, so whole number starting at 1 times the fundamental frequency, f naught, and that's our frequency, and then we convert it back to a note number, and that's our x value. Self.data harmonics x, and then we do 4 times I through 4 times I plus 4 equals n. Okay. So basically, all these fours, what they mean is each harmonic will have 4 data points on the plot that we're plotting. You know, mid, top, bottom, mid. Go to the next one. Mid, top, bottom, mid. Next one, mid, top, bottom, mid. And basically a zigzaggy thing on every harmonic. That's just a way of plotting this